I see it.
Yes.
Okay,
Yes.
thanks. All right, good. So essentially, since we have a lot of folks might be new here, might not be, IT related folks. So I'm just going to go do a quick overview of what an API is, and then I would dive into what API security is and why it's important. So API is just an application or a program to communicate with another program. Generally speaking, when sometimes if you hang out with around programmers, you might hear them talk about APIs and how how those APIs can be used to perform certain tasks. So generally speaking, they usually are used for extracting some sort of data. In our environment, there's a heavy use of APIs to extract, PII data or some other sensitive data, such as social security numbers or course information, sharing amongst colleges. And if you want to grab the new students signing up for new application from a student, you may do that using an API of some sort. So what exactly they are, why they're created. A non technical way of explaining this would be consider if you go to a restaurant and you order some food. When you order some food, you interact with a waiter, and you can order meals, different dishes, drinks, ask questions on the menu, request to pay the bill, and much more. And you can do a whole bunch of things. In this example, a waiter is shielding you from all the complicated stuff that happens behind the scene in the restaurant, that how spaghetti is prepared or some other meals are prepared, where the ingredients are, how your drinks are prepared. So all those information is hidden, right, from you. All you care is you want certain thing and it's delivered to you. So that's how an API works, basically. You don't need to worry about the stove, the oven, the dishes, the managing of stock, pouring of drinks, interaction between you and all of the services that the restaurant have to offer is given to you while through the waiter. So in this case, would be an API. So intuitively understand the useful of an API, right? So their term API stands for Application Programmable Interface, and it's a way of different programs to work together in various ways, various forms. There's 4 ways or different ways in API can use, as I mentioned, at high level, like accessing the data, hide complexities, security, and stuff like that. The main reason we use the API is to basically get data from third parties. In this, like the kitchen example I gave you, the restaurant example I gave you, waiter provides you information, the status of your order, and without you having to go to the kitchen exactly. So you don't need to go to the kitchen. You just tell the waiter, and he goes and grabs you the information you need, or the food you need. So the other example will be, normally that you use a weather app on your phone, or a Google app, or an Apple app, that grabs the temperatures from all over the world. So instead of the app then you use that weather app to retrieve weather predictions on your area, or if you're interested in somewhere else in the world, would retrieve that information for you. These days it's hard to find services that does not have an API. There are APIs to look up recipes, music, lyrics, barcodes, zip codes, parking spots, holidays, whole bunch of things. Aside from just accessing data, APIs can also perform complex or be used to hide complexity and perform tasks. In the restaurant example I used, you don't need to know how someone prepares a sushi, right? So you don't really need to know that detail. You just need to be able to order that thing, and then you would just get a finished meal or ready sushi for you. Another example would be an operating system is our computers and phones. App developers do not need to worry about your Wi-Fi setting, for example, or Wi-Fi connection, or draw shapes onto the screen to make for user interface and talk to various sensors, such as the GPS or some sort. So those types of complexities are hidden from the user or developers, right? So you can use those to hide those things. So instead, what you do, operating system gives developer a bunch of apps, APIs, that simplify their extracting of information. If app wants to show a button on the screen, it just asks system to render it. The app does not need to worry about the device it's running on, and what hardware it has, the screen resolution it has. It doesn't need to worry about that. It masks developers for more efficiently because they can focus on what matters to them most, right? But aside from accessing data, abstracting complexities, API can also be used to extend functionality. For instance, an iOS application can show a widget in Notification Center, for example, and to do that, app notifies the system that through an API that a widget is available, for example, and if the user adds it to their Notification Center, the system will contact the app to ask how it should be display the widget, right? Another example would be Siri or Google Assistants or Alexa that people use normally. These professional assistants are, very, pretty clever. External developers can use the assistants API to extend the functionality further, right? The vendor integrated with the Google Assistant through the API, normally, and Google becomes aware of the new hardware, its capability, and it is able to interact with them. So it's pretty nice way to extend your functionality into something that you normally not using. So the APIs are all around us. You probably have seen messages you get on your phone or to use your location, microphone, and stuff like that we're using right now. So these APIs basically are sort of a gatekeeper for us. So for example, in the mobile platform, the system only has a handful of APIs that can be used to get your location, and because it's a centralized system, it's really easy for iOS, Android to notify you when an app is using your location, right? So it's not the app, but at the same time, you have to worry about the security of these things in terms of permission, in terms of too much access to data, and various things that can potentially impact compromise of or leakage of information. As I mentioned, your phone can ask for permissions, and it can shield sensitive data. This can create some challenges. So, for example, if you're using Google or Facebook account to log into another website, it's fast and convenient, easy. But doing that, you are giving your website or permission to access some of your data, right? So like your email or name or some other sensitive information that might be, that you might be sharing. Sometimes that this, is very convenient and it's, you know, helps you log in, log out, and stuff like that. But the problem is that you are sharing permission as long as it's lasting. So it could be forever, it could be a while. You know, after a while, you might forget what apps or website you gave permission to access your data, right? So those are sort of sensitive things that you need to be aware of. You know, the best way I can describe why API is very important. I don't know if everybody should be familiar. This was a well-known problem that Cambridge Analytica was a, you know, they collected basically massive amount of data through Facebook API. You know, they created personality quizzes and asked permission to get some of your personal data via that. You know, and if you give it permission, the app could silently access your data for months. And, you know, let me see if somebody has any questions. No, okay, that's good. So API acts as a gatekeeper, protecting our. So I'm sorry, I didn't finish. So it gave a permission app silently access your data for months, and, you know, even if you don't realize, it was just basically got all the data it needed, and they're, you know, used for certain things that you may not be aware of. So instead, you had to revoke the permission through Facebook or website. So in short, APIs can act as a gatekeeper, protecting our personal data and only giving it to the apps we choose to. So we should be aware of how long the permissions last and when to revoke them. We no longer need them. So, you know, this is just a basic overview of why, you know, APIs are important. Basically, you can give access to data through multiple services, multiple apps that are working together. You know, it can hide complexities, it can add functionalities, you know, it can do all sorts of, you know, things. So APIs are all around us, as I mentioned, and they're more and more we connect. APIs continue to be an integral part of our business. You know, there's, you know, thousands, if not hundreds of thousands of APIs internally, externally, that makes this management of, you know, security around APIs sort of very difficult. So what is, you know, three main things that you need to be, when you're applying security on APIs that you need to be aware of or understand is very important is the authentication, authorization, and, you know, being able to trace the APIs, right? So authentication, you know, is very important. You want to make sure that the people programs accessing your APIs are properly authenticated, just like you need to use your user account for your systems, or that you log into, you need to have proper authentication. API requires similarly that you don't want somebody inappropriately accessing sensitive information. Authorization, users and programs may, you know, perform sensitive tasks. App authorization list which programs are allowed and which are not allowed. So, I mean, I can give you an example of this. You know, in a hospital environment I used to work many years ago. So we had doctors and nurses. So doctors have certain set of authorizations, so they can look at probably more detail and, you know, compared to a nurse. They probably have more access compared to a nurse would have. So they were in a hospital, they had a bunch of APIs. They go and grab, you know, certain, you know, charts, medical records of a patient. And that's what being done by API. So we had a breach and a leak as a result of, you know, some nurse would having too much excessive access compared to a doctor would have. So, you know, it boils down to, you need to know who is allowed to do its need to know basis. in our environment, we don't want, everybody to be able to see student social security number, address, or, other date of birth information, or any sensitive data. So we want to restrict that. So we need to have proper authorization to, complete those tasks. Trace, other thing is basically trace the calls made by APIs in order to ensure the accountability of parties involved. You can do that through tracing or logging. So you want to strike a fine balance. So these are the main things you need to worry about in APIs. So the protocols, as you know, SAML, not SAML 2.0. You should avoid web WS security. You should avoid basic auth, which sends your security to a network with each request permanently invented for end user, right? So you should avoid those. All right, so recommended things that you need to be worrying about is, go deeper on these things a little bit. API keys for APIs, which is basically server-to-server communication, only provides authentication. So how, generally speaking, how it works is basically simply it identifies, API keys identifies your application and your request for your request. If an API requires a key, you must first be accepted as a user of a service and retrieve your personal information for your API. Once your key with the unique value has been assigned to your user or your API service, you'll be able to use your API in your code, and you can call the API in your program, and API key will be able to be part of your request, and you can make the service with that API key as part of as part of the request service. You're able to identify and log that service you're using, and you often accept your request. If the value is valid, ultimately, you can send your appropriate data in a response. Therefore, in API key is used, can be a good use for identification, authorization, and it's identifying your application request with your API key and checking whether API key has been granted access to send you appropriate data. So API, basically API is responsible for maintaining all the keys and checking the names of each request comes in. If API key is invalid, not mapped or to the user, API will send back an error response. And if it is not to a user, if API is not to a user that has made too many requests with a small amount of time, API will send back an error or looks like a user is attempting to overload the system with some sort of cyber attack. So there are also public private API keys. That's another topic which we don't need to dive in right now. But that's in a nutshell what API key does. OAuth 2, I'm sure a lot of people are familiar with those, people especially in the IT world. OAuth 2 is a widely used authorization framework. It relies on a bearer token for authentication. It enables user to delegate subset of privileges to application in order to protect users, passwords and stuff like that. So it's commonly used. So for example, consider if you want to, in your environment, so going back to API key, if somebody wants to test it out, there's a MTA bus time that you can use for public bus service that's provided. And, you can just, if you want to really play around with that, that's another open source type of thing you can use. OAuth 2, if let's assume you have an external application needs to register with your site, before it can use an OAuth to authenticate your user. Registration application can be used by all the users for your site probably, and just not just for the account, a person registering and for the application. So you would have to build some sort of flow that will enable you to do that, like such as the client ID, client secret, redirect URL. So it involves some sort of authorization flow to authenticate a user application using browsers redirects to send it to wherever you want it to send it to. So it's important to understand these things work on some sort of flow. Once they authorize this application through their browser, it can be redirected. If you allow some sort of implicit grant flow using your URL is directed by including some sort of parameters for the access token, and then those are, you have certain post in your post request, you would have those type of information available. So so this is just a high level view on OAuth 2.0. OpenID Connect is a standardization of OAuth 2. It describes user identity and third party authentication more specifically, and these are commonly used. So you can use OAuth in a confidential, external, and public manner. Those are basic aspects of it. OAuth flow, as I mentioned, if you are is the end user connected or not, yes or no. My app is public, yes or no. So you can do some sort of implicit grant, authorization code grants, and you can build some sort of code, flow related to your your API authorization. If you want to use some sort of a common login form, yes or no. If you want to trust resource owners credentials, you should be able to do those things. Basically, OAuth and OpenID access token and is bound for us on a set of scopes. A scope basically describes the limit of the privileges that user has delegated to an application, and you should only manage a handful scope, hopefully. So you can implement role-based mappings between systems, roles, and scopes such as writers, translators, etc. Domain-based, named after business domains, right? Action-based, they're like access control links based on action-based on scope and templates and stuff like that. This goes a little bit detail on what it is. OpenID Connect again, manages your own OAuth instance and authorize access to API resources. So using your own OpenID providers to authenticate any external OpenID Connect provider to authenticate users such as Google and stuff like that, right? So OpenID Connect lets app and software authenticates user without additional burden of having, storing, and managing passwords in the face of the internet. So it really is well populated with the people trying to compromise user account for their own gain, right? So it really is very hard. JSON Web Tokens are another thing that can be heavily utilized by OpenID Connect, composed of 3-way 64 encoded string separated by dots. This is the syntax. The header explain how to read and check GWT. Content, 64 base 64 encoded JSON, and signatures obviously hash. So What are claims? Claims are information about requests and users or authenticated user authentication event that you can think of as slices of users' identity, such as the email, name, address, that is embedded for validation purposes. Again, little bit more detail on API keys. Basically, a randomized string serves as a shared secret between client and server. You must use a secure channel to exchange the key. Email is not secure most of the time unless you can make it secure, but it's not recommended. A compromised API key must be revoked right away. Query parameters, you may retrieve the API key from query params, get/services, it's pretty straightforward param. Headers are likely to get logged. You should prefer this method. It's very simple. Common pitfalls: do not confuse scopes with the ACLs. ACLs involve two-factor providers. Scope claims are stored in ID tokens. A scope can grant access to a set of claims or limit what an application can access. So you just want to be mindful of OAuth flows. Resource owner is a perfectly valid first step when migrating from a legacy system to a state-of-art authentication service. So you must consider the end of line that it solves none of the issue addressed by OpenID specification, right? So some common pitfalls that you need to be aware of. Error handling is very important from a security standpoint, specifically 500 status. For this 500 status code, you have to be very, very, very careful. Not just for sort of dump your entire stack trace when an internal server error happens. You're giving a hacker the opportunity to sort of reverse engineer and figure out how your application actually works. But at the same time, you want to know you want to know how you think of your end user and make provide payloads that are somewhat helpful for the end user to figure out why an error happened right away. So an example would be 403 forbidden error, and that authentication was successful, but a specific request was forbidden, and it can somewhat be frustrating for the user to sort of get that error kind of error without understanding why it was forbidden. So you can include things as in the payload that would say that you don't have enough privileges or credit to complete certain tasks. The transaction, this transaction right away, can be handled appropriately. So again, going into forbidden error, content type, application, JSON, language, this is the message and this is how you handle it. So monolithic microservice and microservices, related to APIs. Monolithic apps are all but nothing, a big giant thing that they can fit through the shipping door, for example. And microservice apps are continuously updating parts. You can think of as an app within an app. And it can do a whole bunch of things at the same time. Microservice principles, they can be developed independently. Does one thing well: deployment independence, API focus, decentralized data management, easy to scale. Those are some of the things. Pros and cons of monolithic, and pros and cons. Pros is simplicity of small code base, faster or at early development speed, easy testing, ID support. Cons is not ideal for growing code bases, slower iteration in long term, harder to innovate, and code learning curve, code learning curve. Microservices, is better architecture for large applications, better agility in long-term, microservice easy to learn, isolation for scalability and damage control. The cons are, obviously complexity of infrastructure requirement, consistency and availability, harder to test, those type of things. So, just going a little bit into monolithic code bases, as I mentioned, are much easier to get started. They're easier to test, but the problem happens then when the code base starts, exponentially grows. Microservices are not sort of better architecture in the long term, right? So you have to be careful. So when you're designing APIs, you need to consider what sort of impact this you would have in your environment in terms of scalability and security. Figuring out loose dependency with monolithic, problem doesn't exist because you sort of understand all the dependency, from release perspective, and if the monolithic code base becomes so huge, and it becomes a sort of a hassle. And so many dependencies that end-to-end lifecycle management becomes sort of a headache, right? From a security perspective, API design phase, I want to focus on a couple of examples, which is sort of important, such as the pagination attacks. Pagination limits to prevent DDoS attacks. So what you want to be basically aware of is from a design implication of the design in the security right away. Yet, so absolutely have to limit in terms of pagination. Otherwise, you are opening doors for terrible sort of DDoS attack vulnerability where your user can actually request thousands of things and millions of pages at once, try to sort overload your system and bring it down. The many different kind of pagination techniques, and so there's a lot of pagination techniques. Nobody really cares about them as long as it's there. Offsets pagination limit, and offsets are now sorted through you can sort through the SQL database and can be included in this SQL select syntax. So there's you can limit those in terms of 20 or something like that, right? And seek pagination as a result of this. So these, be careful about DDoS attacks. So permission, very important. As I mentioned, permissions are granted to each based on roles. Is very important in terms of APIs and user assignment roles that can restrict, leakage and breaches. Limitation of RBAC, determining the permission to assign to each role is very time consuming, because you have role explosion. RBAC needs attention at all time. And providing a fine-grained access to resources often lead to explosion of RBAC rules, as I mentioned, and attribute rules. So providing a fine-grained access to ensure resource can often lead to these type of problems that needs to be vetted out. I'm going to skip through a few things because I'm running out of time. Sorry about that. As I mentioned, distributed denial of service, API DDoS attacks are executed to overload an API service. Since each hacker sends normal traffic volume, these attacks are difficult to detect. So these are pretty sophisticated sometimes. SQL injection attacks and data attacks with the right credentials, insider and hacker can access any form of data. Example includes data extractions, data injection, malicious code, and those type of things can really happen. So that's all I had for now. So because I'm running out of time, so I skipped through a few things. I apologize. So just briefly on, I can take a few seconds on that. A security can actually cause your entire business to shut down, right? So if you, based on some studies, 60% of the startups actually end up being shut down within 6 months, because the majority of the breaches is due to bad API design or security design, and then APIs are not tested for vulnerabilities and exposing, and they end up exposing some sort of confidential data to that should not be exposed. So we want to basically restrict that. So there was one incident basically happened. I can't remember the name of the company. A few years ago, there was a startup company basically exposed their API inappropriately, and after a year and a half, people were collecting using their API sensitive information. By the time they figured out, it was too late. So we don't want to obviously get to that stage and restrict these things as soon as possible. So I'm just going to stop here because I have other presentations to go. If you have any questions, please let me know.